for my point of view, let's say it like that. But now he's also going to talk about streaming analytics in Cassandra, and he's going to show you some demo. He actually built it in not that many hours either, so let's see what he built. He's going to talk about chickens in New York.
Chickens.
Oh, chickens! Chickens in New York. Well, okay, chickens in New York it is.
Okay, cool. Thank you guys. It was awesome, the first presentation, and yeah, it was really an eye-opener. And I'm a big fan of, let's say, bringing more analytics into our operation and our APIs, because APIs and services, that's what we do. And if we have analytics running on the services, that's actually so much more powerful than what we have today. So basically today I wanted to kind of carry on the discussion that we had during the first presentation with a story about wouldn't that be cool if our APIs would become more predictive and more, let's say, intelligent, more smart for our system. So after some searching around, I found a nice data set. It's a data set of Goala, which is a competitor of, was a competitor of Foursquare. What they call it, localization-based social networks. So it's a network where you tell your friends where you're checking in, whether it is a restaurant, a bar, or just work. So I took this data set with the idea to build something with Cassandra and Spark, and maybe, let's say, a bit more than that. So I used Jupyter, so I still have to try the other one, but this is the one for Python. I use it when I need to clear up my mind and try a few ideas. So I'll just jump to really the core of the idea. We do have a data set provided by Goala that is extremely simple. It's basically two tables that says, okay, we have a bunch of people that between, let's say, 2009 and 2010 have been checking in different places. And of those places, we just have three numbers. We have the longitude, the latitude, and the venue ID. That's all. The second table is a table of venues. The table of venues is basically saying, okay, this venue ID corresponds to a given place, and this place will have also some coordinates and some name. This is extremely fascinating for me because it actually looks, in a way, these sort of scenarios that are similar in so many domains and businesses. And it's nice to talk about this specific data set because it's been studied so much, and I gave it a try myself. So first of all, what I did is having a look at how many check-ins, so how many transactions are happening in this network. So in 2010, Goala and the Foursquare were actually booming. It was the years where everybody wanted to tell around what they were doing, where they were doing, with whom they were doing it. And at the end of this process, actually turned out that actually Goala was acquired by Facebook at the end, while Foursquare they went its own way. So this is an interesting data set. And then I said, okay, let's put it this way. This data set is 6 million data points. 6 million entries. It would be good if I would kind of size it down to the city of New York, so that we can see what's going on in the city of New York in this period of time. And the city of New York is very active. That's good. So in that case, what I try to do is the following. I've brought k-means, which is a very simple and very well-known clustering algorithm that allows you to basically to have an understanding about which areas in the cities are hot in a given moment in time or over a period of months or years. So you can decide yourself whether you want to run a global analytics across a year or more, or if you want to pull down to, for instance, a few hours of check-ins in that area. But no matter whether you do that, the one or the other, at the end of the day, I decided to start looking at the data set and took sets of 4 hours and to see how the city of New York was being populated. And I gave a number of points for my data set, which in that case was I said, okay, somewhere between 10 and 50 sounds like a good number of clusters for the city of New York, and I plotted them now in a map. So in this map you could see, for instance, lower Manhattan, higher Manhattan, so you could see Brooklyn and a couple of other areas. What happens is that now, if you're running analytics, instead of doing the typical, let's say, global analysis, saying, okay, the top K in the year, I can say what's going on, the top K businesses in this area. Because if I'm there and I receive that message saying, hey, I see that you are in higher Manhattan, and have you tried that coffee shop because you're right there? And I know that coffee shop is very popular. So you see here 2 elements which are playing. One element is the analytics as we know it, the traditional reporting schemes and the aggregation and so forth. The other side is the machine learning. The possibility to cluster, let's say, transaction by topics or by density, and define areas where actually this is relevant for a specific user. So if I thought, okay, this is good enough for a demo, but then it comes the moment when the data scientist has to stop playing with his own small data set and needs to implement the idea in a production system that might have much more data. So with that respect, Cassandra and Spark, they form a good combination for this specific case. So I'm going to build on top of what we have just seen, trying to demonstrate how you can take Cassandra, store there your check-ins, your transactions, take Spark, extract the table from Spark with, hey, guess what? A Spark Cassandra connector, and applying some more traditional aggregation techniques, join, merge, filter operation, moving a bit further more in the direction of Spark ML, so machine learning, and applying the algorithm of k-means clustering on this data set, generating a new table, putting that back into Cassandra, and having a service like an API accessing these clusters to provide basically services and predictive APIs basically. Okay, it's a long story, and I'll try to go down to the bottom of it. So the first thing that you always struggle at the beginning is you have to create these tables. That always seems easy, but when you have to deal with time series and you want a specific way of analyzing the time series, it's not that easy as it looks, because you want to make maybe your rows a bit wider, or you need to decide how you're going to query that. So in this particular scenario, what I decided to do is to have, for instance, year, months and day as, year and months as the primary key, defining that portion of the primary key which is actually the row key, so the partition key. While I'm using the day and timestamp to define the clustering key, or the secondary key. I'll always mix up these names. The clustering key, right? Yeah. So basically, the first part will determine how my data is basically spread across my data stacks or Cassandra cluster. While the other part determines pretty much how much data I'm going to store it in a single row. This is actually quite important because the sharding in the row depends on many things and depends a lot on your application itself and the payload that you expect. So for this specific scenario, I'm taking year, month, day, timestamp, UID being the user ID, then the latitude and longitude, the venue ID, and then I'm doing a clustering for ordered by day and timestamp to make sure that if I'm actually selecting a portion of my row shard, I'm actually doing the right thing of having days grouped together before actually going to, for instance, a more refined filter in terms of hours or minutes and so forth. This is not the only way you can do that. There are like zillions other ways you can solve and tackle this problem. This is just one way to do so. Okay, we have then another table, which is the venue table, much simpler, just a venue ID and latitude and longitude. So if you copy-paste this in your SQL shell, you most likely should have had some table. Yeah, tables are there, fine. They are of course empty at the moment. And let's proceed on. So the first thing is, of course I would have done the fancy way, but hey, let's just do the simple way. I just copy using the Cassandra copy operation, and by doing that you will have this data set will be loaded into these Cassandra tables. Once this loading operation completes, I should be able to run a few simple queries just from my SQL shell. For instance, I can select the check-ins from the year 2010, month 9, day between 16 and 13. Yeah. You also see this is nice because now I have the day, I can use it as a range, and if actually that's not enough, I can actually zoom in a day and have a range in my timestamp. If I want to go much farther than that, then I would say Cassandra comes a bit short, so I'm very happy of this integration also with Solr, because actually it allows you to have much more flexibility there. But so far, you can really do that in Cassandra. Moving on to Spark. When you start a Spark cluster and you connect it to Cassandra, the first thing that you need to do is, at least in my case, was to rebuild it from sources, including the Spark connector with Cassandra, because again, it was a bit newer than I expected, but it works pretty fine, and it's actually not too difficult to do. The only thing that you need to do is over here, you pretty much have to say that you have a connector Spark Cassandra, you add it as an external jar, and you slap it in the Spark shell, and the Spark shell is able now to connect Cassandra to Spark. I took a bit of a shortcut over there because my configuration of Cassandra, they're actually set by default in the configuration of Cassandra itself. But of course, if you can refine it, you can have it done in more properly as a configuration of your Spark context. So the first thing that you can do is just here. I mean, you take the entire table of check-ins and you load it in a Spark RDD, which is a check-in RDD, which is nothing else than actually a huge distributed list of all the rows of the Cassandra table. Simple as that. As we saw before, you can start to do a few things with it. So for instance, I can take 10 entries out of the table. Now it's all in memory, so I don't need to care about Cassandra anymore. And I get my Cassandra rows. Yeah? Questions so far? No? Okay. So, what you will do with that is, if you look at the connector, I'm not going to repeat too much what has already been said, but there are different ways you can actually do selection and filtering on both rows as well as columns. One which I've done here is, for instance, okay, if I want to, my venues, when I type .select, remember that all the operations in Spark are actually staged. So they do not actually happen till the moment that you actually use them. So basically, write select, it means that actually when the operation is going to be executed and connect to the Cassandra cluster, it's only going to check these two columns out of the venues table. Then you can, of course, map them and extract them, for instance, by taking the long and the string of the name. And this is okay, but it's not actually that great because, wait a second, I missed one line here. It's not that great because basically forces you to kind of deal with all this type conversion between the Cassandra row types and the native types of Scala and Java. So there are better ways to do so, of course, and one of the better ways is, for instance, either to use a case class, which is in fact, in my case, would be a venue of a VAD and long and a name of a string. And that one will actually allow me to have a simpler way of describing things, because now I can say extract from the Cassandra table, and by the way, do an implicit casting from my Cassandra row to this specific object which I've called venue, which is an int and a string, and the mapping is done automatically by the library. It's actually is quite nice because it allows you to immediately move in the domain of, let's say, your data science objects, rather than sticking in with all these Cassandra rows and native objects. So, well, this one, of course, will provide pretty much the same result. Let me see, I missed an S here. And there you go, only slightly a different format, because now you have, instead of the tuples, you have case classes, objects. So You could do some filtering. One way to do filtering is, of course, and I'm just here copy pasting, because otherwise I would go completely nuts here to do this stuff. But I'm gonna use that tool over there because it's really nice. So if actually you see, if I'm able to type queries which do fit the Cassandra table style, then I actually can do that straight in by doing, let's say, a more fluent Scala syntax. So instead of saying, let's say, of using SQL, I would write .where, and then I write there my query. And if the query indeed is workable by Cassandra, then it will work. If it's not workable, you're gonna get exactly the same error messages that you're gonna get when you're running the query in CQL, because at the end it's using the same driver and it's using the same query builder and so forth. So the conclusion of this step is that, for instance, here I have my check-ins imported as pretty raw Cassandra rows, ready to be worked out. However, there is an even better way to do so, and in my opinion, why do not exploit the advantages of SQL if we do have SQL? And SQL has a fantastic feature in Scala and Spark, because actually SQL in Spark has a specific step in the process which learns the types of your data. So by doing so, it will just deduct from the data which is coming in. Actually it takes some sort of subset, sample set in order to do so. It can deduct actually the Scala types. So I don't even need to go and say, hey, I want to create a venue or a check-in object to wrap it up. I'll just write it straight away, and there I have it. And I think that if you're a data scientist and you're used to Python or R, this is like poetry over here, because every data scientist recognizes this to be a data frame, which is a very, let's say, reliable object used millions of times, accessible by columns. You can do all columns operation and so forth. It's again an RDD, and actually that's the little secret, which is not such a secret of Spark, that Spark SQL is not about SQL. At least it's also about SQL, but it's also a lot about data frames. And data frames means data science. So you can do a couple of great things with these sort of objects. You could, for instance, select columns. I'm going to show later on a few of these examples, but let's go back with our annoying problem of joining. Well, joining, of course, is one of the reasons why we love this combination, and in particular why all the data scientists like to move as soon as possible to Spark, because in Spark it's all in memory. You can join in and you can have your table done properly. So one way, I mean, look how easy it is to join now that you have dealing with this sort of operations. I'll make it a bit bigger. It seems a bit small from here. You just take the venues and you say, okay, this is the select query, store them as a data frame called venue, cache it. It stays in memory, done. I take my second data frame, comes from Cassandra as well, is another table, another select query, store it as a check-in data frame, cache it. It's in memory, it's done. Then with this single command saying, df check-ins dot join venues, where the ID is the same of the other venue ID. That's all it takes. So now I go back to my check-ins venues table, and if I show that up, there is the join, and then I have also the name of the venue attached to this check-in table. So wrapping up, moving, because I think that you're kind of beer thirsty, so I don't want to keep you so long with all this join operation. I want to show you how you run a little bit of data science with Spark once that you have this sort of RDDs. So the simplest thing that you could do is running k-means. Why? It comes almost for free. The only thing that you need to do is to load the necessary couple of import the necessary couple of libraries, and then basically transforming the part of my check-in table. I'll just take two elements of it, the latitude and the longitude. And what I do there is, if you're a bit fluent with Scala, I do a map operation, and I take for every row these two elements, and I encapsulate into a vector. Yeah. Then what I do is, this is our vector, is an Spark MLlib linear algebra vector, and now the only thing that I need to do is to specify the number of cluster, the number of iteration in order to converge towards that particular amount of data set, and then create my clusters. Of course, I don't have, I was a bit in a hurry yesterday at 1 o'clock in the night, so I decided not to install the native BLAS. But of course, it's still running the operation, but a bit slower because there is no, let's say, optimized Fortran library to do the vectorial operation. But of course, it is running. And you could see that the result, because I can calculate my cluster centers, and this location right here, with a little bit of imagination, are the hotspots in New York where things are happening, right? So to conclude, the last part is kind of let's say a little bit kind of to complete the experiment. I create a table of clusters. Now what I do with this table is I'm gonna extract my objects, which are here, and I'm gonna save it back to Cassandra. Huh? That's why. That's why I need a UI for that stuff. It keeps that more separated. Okay, I save it back to Cassandra. Once I do so, my table over here, I hope that I'm not killing here any Cassandra stuff, but if I go back and I look at my my table, I'll just write it up. So these are my clusters stored in Cassandra. Now imagine if you are in the business of creating an targeted advertising. What could happen if I update these clusters every 5 seconds, because now things are going much faster. Since the thing is all loaded up in Spark, I can generate not just the clusters once, but every 10 seconds, every 30 seconds, and so forth. I don't need to go extremely fast. But now this table is available for hundreds of TPS for whatever services you want to build with it. So if you're thinking about how to connect analytics and APIs, this is a very good way to do so. You would have, let's say, a micro-batching, a fast, although not real-time analytics running in Cassandra Spark, and a combination with the APIs. Yeah?
I hope that you don't insert into this table with 5 seconds, every 5 seconds. Do you?
Well, it's a tricky question. I don't know. It depends.
It depends.
Create a lot of, you put a lot of pressure on compaction. Because itself is, somehow you need to compact them on grid. So if you update like very frequently.
Well, it depends how you design your replication strategy, and if you want to have more, let's say, a write or a read dominated scenario. Of course, there can be more tuning here. Absolutely. I mean, I would not.
In memory?
Huh?
Or use in memory?
In memory.
Feature.
The in-memory feature of Cassandra to do so. Well, that part actually I would definitely ask the opinion of the experts which are sitting over here. So definitely this is not, you pointed out a good point, this is not a one-man show. I mean, if you want to do something like this and put it in production, you require something which somebody that knows about algorithms, somebody that knows about infrastructure, something that knows about Spark, Cassandra, and whatnot. I mean, the list is quite long. So, yes, even, let's say, deciding how to create your keys for this specific table in cooperation with the business already would be an interesting, let's say, session to talk about. So the answer is, I don't know for this specific scenario, I actually didn't care much. But I'm pretty sure that no matter what specific tuning is necessary, it's actually possible to create a stream of clusters anyways. And by doing so, you would have basically a predictive API in a box, if you want to say so. Yeah. Well, that was it.